Hi, we have seen that a good source of time series data can be from tables inside of web pages, HTML documents, and the example that we saw that was with the Dallas-Fort Worth temperature data from the National Weather Service. In that example, what we did was we copied all the data, brought it into Excel or some spreadsheet, we'd used Excel, and manipulated it, and then created a data set out of it. So there's two major issues with that. Is one, sometimes that won't be possible. Sometimes you'll find the data that you want, you'll copy it and try to bring it into Excel or some spreadsheet, and it'll all copy it into one cell, or there'll be some other formatting issue that'll make it kind of just a wrangling nightmare. Another issue is, even if you are able to do that, the requirement is, of course, somebody has to be there to do it. So if the data update and you want to do what you did before, is you have to go through all those steps again. Somebody has to be there to copy the updated data. Somebody has to be there to bring it into Excel and to manipulate it and have to remember what you did in the past. And what I'd like to show you is how to potentially solve both of those problems is by doing this programmatically, doing it in the R code. And again, you may only be able to do it in the R code. You might not be able to bring it into Excel or some spreadsheet. And even if you can, you probably don't want somebody spending the time and having the logistics of having to be there each time. If the data update, just run the code again, or maybe you can even run it on a schedule so that when the data do update, you run this code, it goes to the HTML table, it knows how to pull it down, it knows how to clean it up, and then it makes the data set and you move on with your modeling or your plotting. So let me show you how to do that inside of these very simple, inside of the weather service data, the Dallas-Fort Worth temperature data. So this was the example we looked at before, right? We noted that this is the URL on how to get there, and that'll be very important. Of course, if we want to tell the code to go to a table, we have to tell it what website that's in, and then we have to say what table inside that website to go to pull the data from. So I'll go ahead and copy that. Now, one thing you'll need before we go look at it here is Chrome. So you may be able to do this in other browsers, but I know that it'll work in Chrome. So again, I'll just start with a fresh Chrome page there and plop that in, and there, sure enough, is the data. And the National Weather Service says, hey, I'll give them some feedback later. But here are the data. And there's a lot of, it looks like it'd be so easy, but it may or may not be as far as the wrangling are concerned. So the first thing is, here are the data. So let's go over here to our code. And I'd like to also point you over to our GitHub site where you can get Dallas Temp Web Scrape rcode.r. Get this script. I would suggest you use this script as skeleton code, and you can fill in the URL, you can fill in the table reference I'm about to show you how to do, and then you can use this code to just manipulate this code to get to whatever table you want to get to. So again, if we want to get this data, the first step one is to use the URL. I've already got it in there, but if you note, that's the URL I just used. It's the same one. And so that's step one, is I'm going to create an object. You can call it whatever you want. I called it URL, and it's got the website. The second thing to do is, notice I have all these packages here at the first. We're going to use tidyverse. We need the pipe. We're going to need some other functions inside the tidyverse. We need rvest, and we need the zoo package for manipulation. So this is the rvest part. The rvest tells you all about how to pull data from HTML tables and such. So this says from that URL, and then here's from the tidyverse, pipe, and then from that website, and then read some HTML, find this table, and then read that table. So how is it going to know what table to go to? There may be lots of tables in a single website. So this is called XPath, is saying every table has a unique XPath. And notice I've already got it in here. I've already got the reference in here, but how did I get that reference is the key. And so that's what I'm going to show you next, is if you go out to that Google page you just had, here is the table I want. So if I right click on that table that I want and go to inspect, you'll get this nice information over here. And it's got a lot of HTML code that's associated with that website, with that table. So if you kind of highlight over it, you see it shows you what piece of the website that's associated with. And you might have to do a little trial and error, but if you see table down here, it's pretty clear that that table highlights up when I highlight the table. So I'm going to right click on table. And if you come down here to copy, you can reference that table a lot of different ways. You can use JavaScript. There's some other methods. We're going to look at copy path, or copy XPath. Copy XPath there. So if I copy XPath, that's what I needed. I come on back over to my R script. I'm just going to put it right down here so you can see that this is the same as that. That's the same thing. So all I would do in practice, even though it's already there, I'll just show you the step, is to maybe that's empty, and you just paste that that XPath that I just copied from the table right there, and then I'm ready to run it. So let's see what we get. So then I do that, and just like that, I have the data, right? But you'll notice this subtlety, right? These are the little things that can actually take a lot of time to figure out. This is a list. In fact, you can see the bracket, bracket, one, bracket, bracket. A list is an object that holds other objects. So what this is saying is I've got this big container of objects, and in the first slot, I've got the data frame that I want. And so, in fact, if you look at class data right now, it is a list. So what I'd like to do is pull that first object out. That's the data that I want. That's the data frame that I want, and just store that. So that's what this does. This says take that big list, take the first object in that big list, and I just called it the same thing, and rename that data, because that's really what I want when I mean data. And then if you do class data, then it is a data frame. It's also these other types of objects, but really it's just our data. So great. So now that we've done that, we can, it's kind of redundant here, but we can look at the data. And now note that there's not the 1, 1 on there. In fact, if I just do data like that, there's not the 1, 1, bracket, bracket, 1, bracket, bracket, sorry, not the bracket, bracket, 1, bracket, bracket. It's not a list anymore. That is the data frame. Okay. So notice my first step here. The rest of this is just cleaning it up. And so I'll let you, it takes some time to kind of see what this is, but what we'd like to do in the end is have it from the earliest observations, the earliest temperatures, to the latest. Whereas this table has the latest all the way back to the earliest, right? It goes all the way back to 1898. Now notice also that we tend to read things from the left to the right, but right now the latest one is on the right. So if I was to read this data backwards, it would start from the right and go to the left, and it would keep going until we got back down here. So what I'd like to do is have the 77.2 to be the first one, and then the 64.8 to be the next one, and so on and so forth. So in order to do that, right, in order to move this, to have this read, I'm going to have a function that reads it in reverse, that actually reads it going this way. But in order for it to all work out, and you'll have to play with this to see it, I'm going to have to switch December and January. I'm going to have this go from December, November, October, all the way to January, so that when I read it backwards, when I flip this to go from earliest to latest, it reads these all in the right order. So again, you'll have to kind of play around with that, but that's what this code does right here. Is it says take the 13th spot. Notice this is slot 1, column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, sorry, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I want to chop off 1 and 14. I don't need those columns. So I'm going to go from 13, which is December, all the way to 2, which is January. Again, that's going to be, so when I reverse this time series, which you'll see here in a second, it goes from the earliest time points all the way to the latest time points. So what we need to do after that is to flip this just like that. So let's check this out. Let's check it out what it looks like now. So if I do flipped, just like that, now it's going from December back to January. Again, that is so that when we reverse this, all the data will be in order from earliest to latest. So note now that if we come back, just a little couple of reference points here, is that looking back at the data, we're going to have some NAs here. There's going to be one NA for December, and there's going to be 1, 2, 3, 4, 5, 6, 7, 8 NAs at the beginning of the data set once we reverse it. So with that said, there's that NA that was in December, so it just flipped it around. And now what we're going to do is to, first let's make it a matrix. So that's just some formatting issues. We're going to make that a matrix, and then I'm going to make that, well, let's just go ahead and show each step. So this will be flipped as a matrix, and notice that that has now changed it into where we've got this as columns, those as rows, but what I really want it to be is just a list of numbers, not a list, really an array of numbers. So I'll make as numeric, and we'll do that. So we just made all of that a numeric. So notice this has all these row numbers, and those are the columns. Now when I do, I call this flipped DMNT, flipped DMT, flipped MNT, then we'll just have, notice it just has numbers. So it's in those, that's still the NA, and it goes like this, but instead of having 62 comma, right, it's just indexing them. And those are just, that's just an array of numbers. And so now what I'd like to do is reverse them. This is the last one that we want, right? That is the latest value that we have. That's November, in this case, of 21. So I'd like that to be the last one. Now notice if we'll just reverse it. So notice when I reverse it, that's this base R function. Reverse, it's going to put those 7 or 8 NAs at the beginning. So I do that. I flipped it. So flipped MNTR. Notice now I've got all the NAs at the front. 1, 2, 3, 4, 5, 6, 7, 8. And that's 77.2. Notice now that they're in order. And I had to flip December to January, and I had to reverse the order. But at the end of the day, notice 77.2 and 64. This is 77.2, 64.8, 5, 51, 49. If we come back over here, 51, 40.9, so on and so forth. So again, play around with that, but that's why we had to take those steps. So now at this point, I want to trim those NAs. That's a zoo function. The package zoo has this nice NA trim function. So I'll use that. And now if I do flipped MNTR, we'll see that we don't have those NAs anymore. And you have to trust me that it's not at the end, but those leading and trailing NAs aren't there. And if you ever needed to do some imputation, which also a lot of times you have to do, there's a nice impute TS package out there, but we don't need to do any of that here. So we'll go ahead and print out. This is how you can print out all of them. A lot of times you'll find, oh, it says, oh, 479 entries remaining. Here, we'll just print them all out. So if I print those, that's all of the data, just so we can do a little sandy check. 72 to 64 to 51 to 40.9. We already validated that those were the first ones. Notice that the very end ones are 57.7, 72, so 80.5, 70, and 57.7. Whereas if we come back to the data, right, those are the last ones that we wanted to have. These are the last ones, are 80.5, 70.2, and 57.7, so we've done it. We've got everything in the order that we wanted it to be in. So at that point, I will assign it to something called Dallas Temp. Maybe that's what I wanted to call my final data set, and then I can plot it, and we can see over time whatever it is we would kind of want to look at. That's all of the, since 1898, that we are looking at a plot of the monthly temperatures, the monthly average temperatures in Dallas, Texas from 1898 to the present. And so we can try to glean and model and answer and get inference however we like from that data. But we have the data, and we can just run this code all over again. If we just ran it all at once, let's say that the data updated a year from now, we want to redo our analysis, and beyond this code there's even more analysis. Well, I just simply run it again, and it updates and it plots again. So great job. That is how we can use XPath and to get data from tables that are in websites, that are in HTML documents.